Today we're looking at section 7 in chapter 4, which is inverse functions. So let's start here. Our first vocab term is inverse relation. So this is a set of ordered pairs. It's just your list of numbers that you obtain by switching the x and the y. So whatever your original ordered pairs are, just switch the x and the y and rewrite them. So the inverse function is, now that you did that, what would the equation be? So it's shown by a line or equation, and it's obtained by switching the x and the y. So when we were writing those, instead of saying like y equals whatever, we would say f of x equals whatever. And in this case, if we're doing the inverse, we put the inverse symbol, the exponent of -1. That means inverse. So this weird little notation here, f -1 exponent parentheses x, we would read that as the inverse of f of x. Or you could say the inverse function of x. The inverse function of x. So let's take a look at some examples here. This says if one relation contains the element AB, then the inverse relation will contain B, comma, A. So, for example, -3, 16 in the first data set, well, the inverse of that would be -16, 3. Okay, and so on. You see some more examples there. Let's look at another one here. Find the inverse of each relation. They're giving us 4 data points. So imagining a graph, you would have these 4 points on your graph. To find the inverse, flip them. So the inverse is the exact, inverse of those. So the first one was -3, 26, so we have 26, -3, and so on. That's it. Just flip those numbers. That's your inverse relation. So how about this one? So this one's asking us to write the coordinates as ordered pairs, then exchange the coordinates of each pair. So this is written as a table, but it's the same process. So you had to write them first, and now we're flipping them. So it was -4, -3. Now we've got -3, -4, and so on. It does say here, it looks like they flipped a couple of these. Do you see? Oh, they made a mistake. Do you guys see this? They had -4, -3, so these should be negatives. Let's throw some negatives in. Sorry about that. It looks like all the rest of those are fine though, right? They didn't mess anything else up. Okay, just checking. So these should stay negative. There's no messing with negatives here. We're just flipping the order of them. So you do this one. Find the inverse. Pause right here. See what you can do. Which one of these is the inverse of this set? When I worked through it, I got B. So again, we're flipping the x and y, and I got B for this one. Let me know if you have questions on this, all right? So next it says graph the inverse of each relation. If we're going to graph this, and we're going to do the inverse, let's find some points, okay? So what I'm going to do is I'm going to find a data point here, and maybe another one here. I think I did this on the next slide. Nope, okay. Well, anyway, I guess that's what I would do. Find these 2 points, and what I would do is I would say this is 0, 2, right? So the inverse of that would be 2, 0. So this would be our new point. This one is 1, 0. So our new data point would be 0, 1. So we need a line that passes through this. Okay, you might want to use a ruler. That's not a very good line. There's a better one. So check this out. This is a good explanation. Pause right here if you want to read through it. This is just a fun fact for your day. The original slope was -2. Check this out, my new slope. Isn't my new slope, we go from here down 1 over 2. So this is -1 divided by 2. So these slopes, when you're dealing with the inverse, it's the reciprocal. It's not the opposite reciprocal. So these lines are not perpendicular. When we were dealing with perpendicular lines, the slope was, what did we say? The opposite reciprocal. In this case, they're not perpendicular, so they're not opposites. Don't mess with the negatives and positives, okay? If it's negative, leave it. If it's positive, leave it. But we are dealing with the reciprocals here for the slope. It's just a fun fact for your day. You don't need that in order to answer your questions here for your homework, but it can be fun and helpful. So look at this. It says the graph the inverse of this. Let's do the same thing we just did here. So what I did for this one, I think these should be negatives, right? -6, -2. I don't know why those didn't come through. So I'm thinking we could do the same thing that we did on the previous one. So find a point. So this looks like, well, actually, 1, 2, 3, 3. So that point will be the same, right? Because that would be -3, comma, sorry, not negative. Goodness. 3, comma 3. And the inverse of that is still 3, comma 3. So that point is actually still there on the graph. What's another point? Here's one. That's an easy point to see. It's 1, comma 0, right? So the new point is going to be 0, comma 1. So now we need a line that passes, whoa, got kind of crooked here. There. I'd use a ruler and extend that further. You should extend it through this, at least the x-axis. So when you do that, there we go. That's the point that I was talking about, and this is the one, so it actually intersects here. That's kind of cool. Okay, what else? So check your progress. Try this out. Graph the inverse of the relation. So pause right here and see what you can do. So it would be a good idea to grab some graph paper and test it out. Draw it on a sheet of paper and see if you got it. When you're ready, hit play. I went ahead and did it, and I said, here's 1 point. And I said if the original was 3, comma 5, the new point would be 5, comma 3, so I put it here. And then this was the other one I chose. I'm choosing points that cross right on the corner on the lines. It's hard, if I could have chosen like this, but that's like a decimal or a fraction, and I don't really know. Or this one, or this one, or this. Anyway, so I chose ones that are right on the intersection. So this looks like 0, comma -3. So the new point is -3, comma 0. Okay. So I chose C for my answer. Let me know if you have questions. To summarize, here's the new, I guess this is summary of the new concept, the new topic. So we were just dealing with graphing. This one says find the inverse function, inverse of f of x, of the linear function. Okay, so if you're going to do an equation like this, replace f of x with y, and then switch x and y, solve for y, and then replace it again with this notation just to make it official. So let's take a look at what that means. If we're going to find the inverse of this function, I'll move myself over here. Inverse of this function. So first replace this funny thing with y. So we just put y in. Now switch the x and the y. Do you see that? X, y. Get x on a side by itself. Still working. So once you get y on a side by itself. Once you get y on a side by itself, put that new notation back in there. F of x, but we're using the inverse of f of x. Okay, so just a reminder, the little -1 means inverse. This means the function of x. So this would be the inverse function of x is this stuff. So here's another one. We're saying find the inverse, so put in y, and then switch your x and y. So if you put y equals 5/4 x minus 8, switch your x and y, get y on a side by itself. So once you do that, now instead of y, we can put in our inverse function of x notation, and then that's your final answer. They're giving you a couple of different options. You could leave it with this out in front, or you could do the distribution process and leave it like this. You try. Pause right here, see what you can do. When I worked through it, I got B for my answer. So take a look through my work and let me know if you have questions. The next one's asking about Carter selling paper supplies. He makes base salary. Okay, so this is your equation. Find the inverse function. So what we're going to do is put in y and then switch x and y. Put in y, switch, solve for y, replace it with a new notation. So this is saying, what does the x and this thing represent in the context of the inverse function? So in the original one, it said his total earnings was this, and x was the dollars, x dollars. So now we're switching that. We're saying x represents total earnings, and the inverse function of x represents total dollars for the company, monthly sales for the company. Okay. So, let's do another one here. Oh, and this part's asking here, find Carter's total sales for last month if his earnings for that month were $3,450. So what they're saying here is plug this in. If this is the dollars, what do we need to do here? Use the equation that we just had, right? Find Carter's total earnings. So they're saying find the inverse function of this. So 3,450. What we're going to do is we're going to plug that in for x. 3,450. We're going to plug it in here into the equation that we created, right? We created this inverse function. So plug it in and solve and see what you get. It says it's 25,000. So you try here. So pause right here and see what you can do. This is the last example here. See what you can do. Alright, when I worked through it here, I'm going to move myself way up here. What I did is I started out with this, plugged in y, switch x and y, and now get y on a side by itself. So this looked to me x minus 40 over 65. This should have a minus sign in it. Sorry about that. That should have a minus sign, x minus 40 over 65. And then it says, find the inverse function and how long it took the mechanic to fix the car if Nikki was charged a total of $365. Originally total cost was f of x, but since we switched those, we put f of x, or y, we switched the spots, and so now what we would do is instead of plugging 365 in for here, in our new equation we would plug 365 in for x. So I put 365 in for x, and then I solved this part of the equation, so I plugged this into a calculator, 365 minus 40 divided by 65, and I got 5 for this. Okay, let me know if you have questions, guys. I can work through this one again in class, do whatever you need if you're stuck, okay? So feel free to rewind and listen to anything else again. I'm going to go ahead and show you the homework problems. And there should be 11 problems total, so this is 28 through 31, 28, 29, 30, 31. It's matching problems, so I wanted to do a full set of 4 here. Okay, let me know if you have questions.